Our next speaker is Joshua Kaggie, and he's going to be talking about federated deep learning in clinical applications.
Thank you. Okay, so I'm going to discuss more of a systemic problem rather than the mathematical problem with deep learning, which is the fact that we're all reliant on requiring data, and we need data for our clinical applications to prove that our systems work, and we require diverse data sets. So that may be diversity of age, gender, region, disease type, and we're often limited in our data if we're working on a rare data set. Even with common data sets, we may be limited for the type of annotated data we have or the population of data that we have. So to really get a lot of data, we require collaboration. And one of the difficulties that we all have if we're working with medical data is that you have to get data out of the hospital. The hospital has a requirements and I'd say a duty for patient security and privacy, but also may have concerns about IP. So it can be very difficult to get data out of a hospital. And this is compounded if you're working with national or international collaborations across hospitals. And so if you're trying to even work within the university and our hospital or with other hospitals, you might have to work with some of the lawyers or other governance structures. You usually have to have an ethics application. And if you're working internationally, then you have even greater concerns. But one of the ways around this that is proposed is to use what's called federated learning. And this is an example of federated learning that we had done at the in 2020 at the end of it over COVID. And so Cambridge being one of the only sites in Europe to contribute to this data set, we worked with 20 different sites across the world to contribute to an X-ray data set called exam. And the contribution from Cambridge came from multiple sources. One is the EPICOB data set that was collected here that collected electronic health record data, and we also collected DICOMs of patients here. And so for the exam machine learning model, we collected demographics, vital signs, lab data, and chest X-rays. And the specific machine learning network looked a bit like this, where we had a pre-trained ResNet and all of these different metrics, and collected that across the 20 different sites. What happened then is that each site trained on a local model that then was sent to a global model. And then after the global model was updated, the global model would train and then send that back to each of the local sites. And this would happen iteratively. And the prediction that we tried to use was the type of oxygen device a person would need after 24 or 72 hours after being admitted to the hospital. And you can see the diversity of data. So here are 20 different sites here. And on the top right, you see a number of different images that vary between sites. So with the greatest site being 3,000 and the lowest site being less than 100. And so with this type of variation, and even in patient age variation, and with the type of location, this would benefit, in particular, the smaller sites, but also the larger sites. And looking at particular results, every site improved when we had this federated learning model. And we were able to have a very good AUC for predicting a person's oxygenation device after 24 hours. And considering the shortness of time, we're also working with brain aneurysm detection with a spin out from this project and with a company called Rhino Health. And that has been quite enlightening in the sense that different types of manufacturers have different abilities to work with this machine learning model. Different locations also are more predictive than others. But the point being that this machine learning federated approach can help enlighten on new factors and also help increase data sets that may otherwise not be available simply because you're able to use just a local training set and a local and keep that data within your local sites while you're just sending the model across to a distant location for updating. And then just in summary, well, not even summary, if anyone has an image data set that they'd like to work on with federated learning, or even a model that's based on images, please contact me or radiology, people in the radiology department. And let's see whether we can explore some of these types of federated learning approaches.
Brilliant. Thank you very much.